Okay, I would like to repeat how to prepare the PDB file for the protein ligand. First of all, you use VMD. You check atom selection that you want to save by using this menu, graphic representations. Here in this selected atom box, we need our chain A and protein. This text is used for preparing the protein PDB file. Okay, this one just protein do not have inhibitors. So we need to highlight, activate this. Hide this text in the save in the file menu, and then select save coordinates. Okay, in this save coordinates. So save data from here, you have to select the collect object, which is this one. You see, and then here you type the text chain A and protein. Yeah, exactly the same text. You put it here. Just put it in this window and save. Then this is protein. So you save the file name called protein.pdb. Save the file. Okay, and the file we need, and the next one is ligand. Ligand has we need to put. Okay, let me show you this one. Ligand you type chain A and last name G39. Okay, and then enter. And do we see that this a little, okay, makes larger. So for this command, it select ligand atoms, and you want these coordinates as a ligand PDB.pdb. So you type in this save trajectory window, in this window, you type exactly the same chain and last name 39, save. Okay, every time we have to, I have to select a proper object. Ligand, save it as ligand.pdb. Save. Okay, and you also need a complex protein and ligand together. This is for comparison. After docking, you compare with this reference. The text, we just type chain A. This text we type, if you select protein and ligand molecule together. Save. I save it as a complex. Now you have complex.pdb, ligand.pdb, and protein.pdb. Okay, next, double click to call Docking-02. You will have window like this. The next step, you can follow this PowerPoint file. Okay, by the way, I would like you to notice there are two menus here, the upper one and lower one. You see that? So the lower one is usually used to prepare parameter for ligands. The upper one we usually use prepare parameter for protein. Okay, first of all, we load protein. We go to open protein, use the upper menu of protein file. So go to file, lead molecule, select the protein.pdb. If the PDB is loaded correctly, you will have a structure representation look like this. Then lead molecule. Oh, okay. By the way, you can set a default folder as your working folder. Right now, my default folder is not correct. So you can set a default folder by going to File menu, choose a preference, and set. Okay. and go to this startup directory. This one, you can set up default folder. Set up your current, your working folder as a default folder. So my default folder should be /temp and /docking. Actually, you can copy and paste. Copy. Control C and then Control B here. Okay. The other parameters should leave it as it is. And it is just change the startup directory. Click set. Okay. One click here. Then okay. I am in the correct folders. Go to protein, PDB. Okay, color look a little bit different, but that's okay. If I press the right button, it change to ADT2 is another molecular visualization software. Can visualize molecule in a different representation. Yeah, you can pair with the molecular surface representation. Anyway, we go to the point that we need to do. Okay, next step, add hydrogen. Okay, go to the menu and then select edit hydrogen, add, select all hydrogen and click OK. Go to edit, add hydrogen, add all hydrogens. Yes, and click OK. Okay, you can see now hydrogen is now added. The next step is save as a PDB-QT file. The SI chart. Oh, you have to do it this way. So SI charts on atom type and save it as a PDB-QT. Go to grid, macromolecule, choose select molecule. Grid is here. Go in this menu, click macromolecules, choose select protein here, select, and you will see hydrogen will merge. Get initialized protein.pdb contain no non-bonded atoms found. Okay, just click OK, and it's automatically saved. You can leave extension with the PDB-QT. Save it as protein.pdb-QT. Okay. Now we have protein.pdb-QT ready. Since my PowerPoint, the protein I use, what we call is a merged hydrogen atom structures. What does it mean, merged hydrogen atom? It means that only polar hydrogens will be added to the structures. You can see the white color attached to oxygen or nitrogen only, but the hydrogen connect to the carbon, you don't see it. This is we use the merge model. I also use hydrogen merge model. You can see that there is no hydrogen attached to the carbon atom. Let me try again preparing the protein. Delete it. Go to File, Delete Molecule, Protein, Open. And I need to add hydrogen. Merge non-polar. Okay, if I select this command cannot be done if you continue to do undo list with reset. We want to continue. Okay. So no, doesn't work. Let's do it again. Let's find preference, set. Deja vu, not related, interaction, auto merge. Okay. Okay, I set it to 1. Okay, this is I use auto merge set. Dismiss. Let's do it again. Great. Macromolecules. Choose protein. Select molecules. Okay, now it's merged. You can see right now the white color has attached to nitrogen or oxygen only. Use this as a working model. Okay. Next, we prepare the ligand.pdb Qt file. So I have to go in this way. Open pdb ligand. We take 7 rotatable bond. Ligand torsion 3. Choose torsion. Okay, if I choose this, by then save, go to output, save pdb qt. Okay, now I have ligand.pdb-qt, protein.pdb-qt. Okay, next step, we gonna define a boundary, an area for ligand to search the binding site. To do this, go to this menu, grid box. Okay, go to grid box. And after you select it, you will see a box inside the protein. You will see, right? You see a box with red, blue, and green color. This box tells you where the region for the ligand molecule to search. If you know the binding size, or you have some idea where the location of the inhibitor is, you might focus the search on that region. But if you do not have any clue about the binding site, then you might do a very large area for the search. You can change the boundaries for ligand search by changing this value. This is changing the number of points in the X, Y, Z dimension. You can play around this. The value for the search region should be. And you can move the center of the box. For example, you can shift where the centers of the box is. So typically, if you have idea about where the binding site is, you can put this XYZ center correspond to the center of the region you want to search. Show you can shift the center of the box. Okay, this is a little bit out, down, left, right. Here I'm gonna use already set value here. That means the center is 0. Center Y is 80. And center C is 110. And then size of XYZ is 20 by 20 by 20. Once we know we have these parameters, dimensions in X, Y, Z and centers of the tick box. Then we have to record this value because we are going to define this parameter in the docking input file or configuration file. Okay, the next one is I need a file called config.txt. It's a text file. Okay, here. And in config.text, open. What I have to do is just type these parameters in the config.text. So I do copy and paste and save the file. So this is the input file we use for, we have protein.pdb-qt, we have ligand.pdb-qt, and this is the output file right in the PDB, out.pdb-qt. This is the center of the box, and this is the size of the box. Total binding mode will be listed in the output file. Save. Okay, next you run a software called AutoDoc-VNAR, and in this software you have an executable file called vnar.txt. So you can run this AutoDoc-VNAR in Windows. Okay, this is in workshop. Okay, 2019. This is in workshop. 2019. You need T file here. When you install, you can copy this T file. VNAR script is used for analyze the results. I'm going to copy this file and put it in my working folder. All right, and to run docking, we run on the window prompt. So I type CMD in the window. I have command prompt window. So this is similar to what we did for NAMD. We run NAMD on window. We use a command prompt window. So I change to the folder, then go to temp and type VNAR and followed by this input. So it has to be dash config and conf.txt. This is the input file minus the log, and this is the log output file. And it will take just minutes. It does not take long.